Dr. Zexthala walked across the Pacific Maritime University campus with her forearms swinging in what humans called a nervous rhythm. Her blue skin caught the morning sunlight as students stopped to stare at the alien professor, who had been living among them for 3 months now. She stood nearly 7 feet tall with large compound eyes that could see things humans could not imagine, and a mouth full of small teeth that clicked when she spoke English. The alien professor carried a tablet in one of her upper hands while her lower hands held a cup of coffee that she had learned to enjoy during her stay on Earth. The coffee was one of many human customs that fascinated her scientific mind. On her home planet of Kepler 442b, the people drank a blue liquid that tasted like metal and gave them energy for exactly 4 hours. Human coffee was unpredictable and came in hundreds of different flavors that changed how people felt in ways that made no sense to her ordered thinking. She entered the marine engineering building and climbed the stairs to the 3rd floor where her human partner waited for their weekly cultural exchange project. The hallway smelled like salt water and machine oil mixed with the chemical scent of new materials that the students used to build their water vehicles. Pictures of boats and ships covered the walls along with awards and certificates that spoke of human achievements in conquering the oceans of their world. Jake Martinez sat at a workbench in the laboratory, space assigned to their project. He was 22 years old with dark hair that always looked messy and brown eyes that seemed to light up whenever he talked about engineering problems. His hands were already dirty from working on some mechanical device that he quickly pushed aside when he saw Dr. Zexthala approaching. "Good morning, Dr. Zex," Jake said, using the shortened version of her name that most humans preferred since her full name was difficult for their single tongues to pronounce correctly. "Ready for today's cultural demonstration?" Dr. Zexthala set down her coffee and activated her tablet, which displayed the assignment she had prepared for this session. She had spent considerable time researching human water transportation and had been surprised by the complexity of their solutions. On Kepler 442b, her people used simple floating platforms, made from natural materials that grew in their shallow seas. These platforms were lightweight and required no maintenance since they dissolved harmlessly back into the ocean after a few uses. "Jake Martinez of Earth," she said, using the formal address that her species used when beginning important communications. "Today I would like to observe human methods of water transportation construction. On my world, we create basic floating devices for moving across water bodies. I request that you demonstrate how humans approach this same basic need." Jake leaned forward with interest as Dr. Zexthala continued explaining her assignment. She showed him images on her tablet of the simple, foam-like platforms that her people used on their homeworld. The platforms looked like large rectangular pieces of organic material that could support one person and moved by pushing against the water with simple paddles. "I have calculated that this demonstration should require approximately 4 of your hours," Dr. Zexthala said while making notes on her tablet. "The floating device needs only to support one person and move across calm water for short distances. This appears to be a basic engineering challenge that should provide good insight into human problem-solving approaches." Jake stared at the images on the tablet and then looked around the laboratory that surrounded them. The space contained advanced 3D printers, computer-controlled cutting machines, tanks full of different chemicals and materials that could be shaped into almost any form imaginable. Tools hung from every wall and workbenches held projects in various stages of completion. This was not a place for building simple floating platforms. "So you want me to build something that floats and can carry a person across water?" Jake said slowly as his mind began to process the request. "Correct," Dr. Zexthala replied. "A basic floating device similar to what my people have used for thousands of years. Nothing complex or advanced, just functional water transportation." Jake nodded, but his eyes had taken on a particular brightness that Dr. Zexthala had observed in humans before when they encountered engineering challenges. She had noted this expression in her research as solution excitement response, though she did not yet understand why humans became energetic when presented with problems to solve. "When you say basic floating device," Jake said carefully, You mean something that will safely carry a person across water and get them to their destination? Yes, exactly, Dr. Zexthala confirmed while recording his response. Simple, efficient, and adequate for the task. Jake stood up and walked to the window that looked out over the university's marine testing facility. Below them, he could see the large tank where students tested their projects, and beyond that, the bay where advanced prototypes were taken for real-world trials. His reflection in the glass showed the expression that Dr. Zexthala was learning to associate with humans who had just been given an interesting challenge. I can definitely build something that floats and carries a person across water, Jake said, turning back to face the alien professor. When do you want to see the demonstration? I had planned for us to complete the construction this afternoon and test the device tomorrow morning, Dr. Zexthala replied. This should provide adequate time for such a straightforward project, Jake grinned, which was a human facial expression that still made Dr. Zexthala slightly uncomfortable despite months of studying human behavior. The showing of teeth seemed aggressive to her species, but she had learned that humans use this expression to indicate pleasure or amusement. Dr. Zex, I think you're going to find human water transportation very interesting, Jake said as he began pulling reference books from the shelves around the laboratory. We definitely have our own approach to solving floating problems. Dr. Zexthala made more notes on her tablet as she observed Jake's immediate engagement with the project. Human behavior continued to surprise her with its intensity and complexity. On her homeworld, when someone requested a floating platform, the response was simply to gather the appropriate materials and assemble them according to traditional methods that had remained unchanged for generations. Jake, however, was already sketching ideas on a piece of paper and making calculations that seemed far more complex than necessary for a simple floating device. Dr. Zexthala watched with growing curiosity as her human partner began what she assumed would be a basic afternoon construction project. Jake Martinez stood up from his workbench and walked toward the door of the laboratory with a purpose that made Dr. Zexthala feel slightly concerned. She had expected him to gather some basic materials like wood planks and rope to construct a simple floating platform similar to what her people used on Kepler 442b. Instead, Jake seemed to be heading somewhere else entirely. Where are we going, Jake Martinez? Dr. Zexthala asked as she followed him out of the small project room and down the hallway. Her forearms moved in what humans had learned to recognize as her nervous gesture while her compound eyes tracked the unfamiliar route they were taking. To the advanced fabrication lab, Jake replied without slowing his pace. If we're going to build a water transportation device, we need proper equipment and materials. The basic workshop doesn't have what we need for this project. Dr. Zexthala felt her confusion growing as they walked deeper into the marine engineering building. She had researched human water transportation before designing this cultural exchange assignment and had seen images of simple rafts and basic boats that appeared to be constructed from readily available materials using hand tools. The floating platforms her people used required only natural foam materials and basic cutting implements. They entered a large room filled with machines that hummed and glowed with electronic displays. The advanced fabrication laboratory contained equipment that Dr. Zexthala recognized as being far more sophisticated than anything her own people used for their simple transportation needs. Computer screens showed complex three-dimensional models, while robotic arms moved with precision that exceeded biological capabilities. Lisa, Jake called out to a young woman who was working at one of the computer terminals. I need to use the carbon fiber reserves for a cultural demonstration project. Can you help me access the material storage? Lisa Park turned around and smiled when she saw Jake approaching. She was a third-year student like Jake, with short black hair and intelligent eyes that immediately focused on the alien professor following behind him. Dr. Zexthala had met Lisa briefly during previous visits, but had not interacted with her extensively. Sure, Jake, what kind of project are you working on? Lisa asked while saving her work and turning away from the computer screen. Dr. Zex asked me to demonstrate human water transportation construction, Jake explained as he began pulling up holographic displays on one of the design terminals. She wants to see how we build floating devices for carrying people across water. Lisa looked at Dr. Zextala with the expression humans used when they were trying to understand something unusual. So you want Jake to build a boat? I requested a basic floating device, Dr. Zextala clarified while making notes on her tablet. Something simple and functional for moving one person across calm water. On my homeworld, such devices require minimal construction effort and basic materials. Jake was already sketching preliminary designs on the holographic interface while Lisa watched over his shoulder. Dr. Zextala observed that the images Jake was creating appeared far more complex than the simple platforms she had envisioned. His design included curved surfaces, multiple layers of material, and what appeared to be various mechanical components. Jake, this looks like you're designing an actual seaworthy vessel, Lisa said with excitement in her voice. Are you planning to build a real boat for the demonstration? Why wouldn't I build a real boat? Jake replied as if the question confused him. Dr. Zex asked for something that carries a person across water safely and efficiently. A properly designed boat does that better than anything else. Dr. Zextala felt compelled to interrupt this conversation before it proceeded further away from her original intent. Jake Martinez, I believe there may be a misunderstanding about the scope of this assignment. I intended for you to construct something equivalent to this. She showed them the images of her people's simple foam platforms on her tablet. Jake and Lisa both studied the images carefully. Dr. Zextala could see them processing the information and comparing it to their own understanding of water transportation. Their expressions suggested that they found her people's approach to floating devices rather primitive, though they were too polite to say so directly. Those are interesting, Dr. Zex, Lisa said diplomatically. Very efficient for calm, shallow water. But if you want to see how humans approach water transportation, Jake's right, that we should build something that demonstrates our engineering capabilities. I can build a foam platform if that's really what you want, Jake added while continuing to work on his design. But it would only work in perfect conditions and wouldn't be very safe or reliable. Human water transportation focuses on handling various conditions and providing multiple safety features. Dr. Zextala realized that she was witnessing something her research had not prepared her for. The humans were not simply misunderstanding her assignment, they were fundamentally approaching the problem from a completely different perspective. On Kepler 442b, when someone requested a floating device, the response was to build exactly what was requested, nothing more and nothing less. Jake continued developing his design while Lisa began gathering materials from the laboratory storage areas. Dr. Zextala watched in growing amazement as other students noticed the activity and began offering assistance without being asked. Within an hour, the project had attracted 5 additional human students who each contributed specialized knowledge to what she had intended as a simple demonstration. We should use the new biodegradable polymer composite, suggested Danny Kim, a materials science student who had stopped by to see what they were building. It's stronger than fiberglass but completely environmentally friendly. Good idea, Jake agreed while modifying his design to incorporate the suggested material. And we can add solar panels for auxiliary power without adding much weight. Dr. Zextala found herself documenting every detail of this unexpected development. Her original research proposal had anticipated observing one human construct a basic floating device using simple tools and readily available materials. Instead, she was witnessing a collaborative effort involving multiple humans, advanced manufacturing equipment, and materials that exceeded anything her own technologically advanced civilization used for water transportation. On my homeworld, she said aloud while making voice recordings, this task would require one individual, approximately 2 standard time units, and materials that naturally float. Humans appear to require multiple individuals, advanced manufacturing equipment, and materials that must be engineered to achieve flotation. Amy Chun, another student who had joined the group, looked up from the computer where she was running structural analysis on Jake's design. Dr. Zex, are you saying your people don't engineer their floating devices for different water conditions? Our water bodies are uniform in depth and weather conditions, Dr. Zextala explained. Engineering for variables is unnecessary when the environment is predictable. The humans exchanged glances that Dr. Zextala was learning to interpret as their response to concepts they found difficult to understand. She realized that human water transportation had developed in response to unpredictable and dangerous conditions, while her people's simple platforms worked only because their environment posed no significant challenges. Jake's design continued, evolving as more students contributed ideas and expertise to the project. The Advanced Fabrication Laboratory transformed into what Dr. Zextala could only describe as organized chaos as Jake's simple floating device project evolved into something far beyond her original expectations. Students moved between workstations, with materials and tools while computer screens displayed complex calculations and three-dimensional models that updated continuously as the design progressed. Jake stood at the central design terminal directing the construction process like a conductor leading an orchestra. His initial sketch had evolved into detailed blueprints that specified every component of what was clearly becoming a sophisticated watercraft rather than the basic, floating platform Dr. Zextala had envisioned. Lisa, can you start the carbon fiber layup for the hull sections? Jake called out while reviewing stress analysis data on his screen. The computer says we need 3 layers minimum for the load requirements, but I want to go with 4 for safety margin. Lisa Park nodded and moved to the materials preparation area, where sheets of carbon fiber fabric waited to be cut and shaped. Dr. Zextala followed her with genuine curiosity about human construction methods. On Kepler 442b, her people simply harvested natural foam materials that required no processing or modification. Dr. Zex, would you like to help with the layup process? Lisa asked, as she began cutting carbon fiber pieces, according to the patterns displayed on her tablet. It might give you good insight into how we approach materials engineering. Dr. Zextala accepted the invitation and found herself learning to handle the strange black fabric that would somehow become the structure of Jake's floating device. Lisa explained that carbon fiber was stronger than steel, but much lighter, and that the layup process involved carefully positioning multiple layers to create optimal strength in all directions. On your homeworld, how do you ensure you're floating platforms are strong enough? Lisa asked while demonstrating the proper technique for removing air bubbles from the carbon fiber layers. Strength is not a primary concern, Dr. Zextala replied as she attempted to copy Lisa's movements with her 4 hands. Our water bodies have no currents, no waves, and no weather variations. The platforms need only support body weight in calm conditions. Lisa paused in her work to stare at the alien professor with an expression of disbelief. No waves at all. No storms or rough water, correct? Our planet's water systems are very stable and predictable, Dr. Zextala confirmed while struggling to maintain proper pressure on the carbon fiber. Weather modification technology eliminated natural variations thousands of years ago across the laboratory. Amy Chun looked up from her computer modeling work with obvious amazement. That explains why your people's floating devices are so simple. You never had to deal with real ocean conditions. Jake overheard this conversation and walked over to examine Dr. Zextala's layup technique. No wonder you thought this would be a 4-hour project. If Earth's oceans were calm and predictable, we probably would still be using log rafts. Dr. Zextala realized that her assignment had revealed something unexpected about the fundamental differences between human and Kepler 442b engineering approaches. Her people had achieved technological advancement by controlling their environment to eliminate variables, while humans had achieved advancement by creating solutions capable of handling unlimited variables. Jake, your design specifications seem excessive for calm water transportation, Dr. Zextala observed while watching him review hull strength calculations. Are these safety factors necessary for the demonstration? Dr. Zex, I'm not just building something for calm water, Jake replied as he made adjustments to the structural design. I'm building something that could handle real ocean conditions if needed. That's just how we approach engineering problems. Danny Kim joined the conversation while mixing polymer resin that would bind the carbon fiber layers together. It's actually more work to engineer something that only works in perfect conditions. Our design tools and manufacturing processes are optimized for creating robust solutions. Dr. Zex Dalla documented this insight with great interest. Human engineering had evolved to assume worst-case scenarios rather than ideal conditions, which explained why their solutions appeared excessive. When viewed from her people's perspective of controlled environments, the construction process continued throughout the day, with students taking turns at different tasks as the project demanded various specialized skills. Rob Sullivan handled the precision cutting of structural components, while Amy managed the computer modeling that ensured all parts would fit together properly. Danny supervised the chemical processes involved in curing the composite materials. This is the first time I've seen a cultural demonstration project turn into a full fabrication exercise, commented Professor Murphy, who stopped by to observe the unusual activity in his laboratory. Jake, what exactly are you building? A basic floating device for Dr. Zex's cultural exchange assignment. Jake replied without looking up from the hull sections he was carefully joining together. She wanted to see how humans approach water transportation construction. Professor Murphy examined the work in progress and smiled with the expression Dr. Zex Dalla had learned indicated human amusement. This is considerably more than basic. Jake, you're building a legitimate small craft, but it will float and carry a person across water like she requested, Jake pointed out, as if this justified the complexity of his approach. It just does it really well. Dr. Zex Dalla observed the interaction between Jake and his professor with fascination. On Kepler 442b, a student who exceeded assignment parameters would be corrected for inefficiency. Here the professor seemed pleased, rather than concerned about Jake's excessive response to her simple request. As evening approached, the floating device began to take recognizable shape. The sleek hull emerged from its molds with smooth curves that Dr. Zex Dalla found aesthetically pleasing despite her confusion about its complexity. Jake and his team had created something that looked more like a work of art than a simple transportation device. The solar panels should be ready for installation tomorrow morning, Amy reported while reviewing the day's progress on her computer. And Danny's polymer work exceeded all the strength specifications. Perfect, Jake replied as he stepped back to survey their accomplishment. We should be ready for water testing by noon. Dr. Zex Dalla stared at what had emerged from her simple assignment request. The device that would demonstrate human water transportation bore no resemblance to the basic floating platform she had envisioned. Instead, Jake and his collaborators had created something that appeared capable of performance far exceeding anything her own technologically advanced civilization used for water travel. Jake Martinez, she said, using the formal address that indicated serious academic inquiry. I believe this demonstrates human engineering approaches very clearly. However, I am curious why you chose to exceed the assignment parameters so significantly. Jake looked at her with genuine confusion, as if her question made no sense to him. Dr. Zex, you asked me to build something that would safely carry a person across water. This does that, but it also does it efficiently, reliably, and with style. Why would I build something inferior when I have the knowledge and tools to build something excellent? Dr. Zex Dalla realized that she had just received the most concise explanation of human engineering philosophy possible. The morning sun reflected off the calm surface of the university's marine testing facility as Dr. Zex Dalla walked beside Jake toward the dock where his floating device waited for its demonstration. She had spent considerable time during the night reviewing her notes and trying to understand how her simple assignment had evolved into the construction of what appeared to be a sophisticated WATRCRF2. Jake moved with obvious excitement as they approached the sleek vessel that gleamed under the morning light. The 12-foot craft bore little resemblance to the basic floating platform Dr. Zex Dalla had requested, yet she could not deny that it was undeniably beautiful in its design and construction. The carbon fiber hull curved gracefully while solar panels integrated seamlessly into the deck surface. "There she is," Jake announced with pride as they reached the dock. "Ready for her maiden voyage?" Dr. Zekstala examined the vessel more closely in the daylight and realized that Jake's team had incorporated features she had not noticed during the construction process. LED navigation lights were mounted at appropriate positions, while a small GPS unit occupied a protected position near what appeared to be a steering system. A storage compartment built into the forward section could hold supplies for extended journeys. "Jake Martinez," she said slowly while making detailed observations on her tablet. "I believe there may have been significant communication errors in my original request." Jake looked genuinely puzzled by her statement as he performed final checks on the various systems his team had installed. "What kind of communication errors?" "Dr. Zex, you asked for something that could carry a person across water, and that's exactly what this does." "Yes, but I intended something considerably more minimal in design and capability," Dr. Zekstala replied while studying the sophisticated equipment that surrounded the pilot's seat. "This appears to exceed basic transportation requirements by substantial margins." "Oh, you mean like a raft?" Jake said as understanding dawned on his face. "Yeah, I could have built a raft in about 2 hours using some logs and rope." "But why would I build a raft when I can build a proper boat?" Dr. Zekstala found herself unable to answer this question in a way that made sense from a human perspective. On Kepler 442b, the response would be obvious, since building beyond requirements represented inefficient resource allocation. Here Jake's logic seemed perfectly reasonable to everyone who had contributed to the project. Lisa Park arrived at the dock carrying safety equipment, including life jackets and emergency communication devices. "Ready for the test run?" she asked, while handing protective gear to both Jake and Dr. Zekstala. "The bay conditions are perfect with light winds and minimal wave action." Dr. Zekstala accepted the life jacket with some confusion, since her original floating platform concept would have been tested in the calm, shallow water of the campus pond. The fact that Jake intended to take his creation into the actual bay suggested capabilities far beyond what she had requested. "Is open water testing necessary for this demonstration?" she asked while struggling with the unfamiliar safety equipment that humans required for water activities. "Not necessary, but definitely more fun," Jake replied as he completed his pre-departure checklist. "Besides, this boat was designed for real water conditions, so we might as well test it properly." Jake helped Dr. Zekstala step aboard the vessel and showed her where to sit for optimal comfort and safety. The craft felt remarkably stable under their combined weight, while the composite construction eliminated the flexing and creaking that she had expected from waterborne transportation. "Just so you know, Dr. Zex, this boat draws about 8 inches of water, so we can operate in pretty shallow areas if needed," Jake explained while familiarizing her with the basic controls. "But the hull design also handles choppy water really well if conditions change." Jake started the electric motor with a quiet hum that surprised Dr. Zekstala with its smooth operation. On Kepler 442b, their floating platforms moved by manual paddling, which limited both speed and range. The human approach of adding mechanical propulsion opened possibilities that her people had never considered necessary. They moved away from the dock with Jake managing the steering while Dr. Zekstala observed every aspect of the vessel's performance. The boat responded immediately to directional inputs while maintaining perfect stability, even when Jake made sharp turns to demonstrate its handling characteristics. "How does it feel, Dr. Zex?" Jake asked as they entered the main channel leading toward the bay. "Different from your people's floating platforms." "Considerably different," Dr. Zekstala admitted while gripping the sides of her seat as they encountered their first real waves. "Our platforms would not function in these conditions," the boat handled the moderate wave action with ease, cutting through the water while maintaining a smooth ride for its passengers. Dr. Zekstala realized that Jake's excessive engineering approach had created capabilities that far exceeded the calm water limitations of her people's transportation methods. "Want to see how she performs under sail?" Jake asked while reaching for controls. That would deploy the sailing system his team had integrated into the design. You installed wind propulsion as well, Dr. Zextala observed with amazement as Jake raised a compact but efficient sail that immediately caught the morning breeze. Backup propulsion, and because sailing is fun, Jake explained as the electric motor automatically reduced power while the wind took over. The solar panels keep the battery charged, but sail power extends our range indefinitely. The boat heeled slightly as the wind filled the sail but remained perfectly controllable while Jake demonstrated how the steering system adapted to wind-powered operation. Dr. Zextala found herself experiencing emotions she had not anticipated during what she had planned as a simple academic observation. "This is considerably more exhilarating than I expected," she admitted while watching the shoreline pass by at speeds impossible with her people's manual propulsion methods. "That's because we built it right," Jake said with satisfaction as he adjusted the sail for optimal performance. Human engineering focuses on making things work well, not just work adequately. They spent the next hour exploring the bay while Jake demonstrated various capabilities of his floating device. The GPS system tracked their route. The storage compartment proved useful for holding Dr. Zextala's recording equipment safely. Solar panels maintained electrical power while the motor provided reliable backup propulsion when wind conditions changed. "Jake, this vessel exceeds the performance specifications of our most advanced water transportation," Dr. Zextala finally admitted as they returned toward the university dock. "Yet you constructed it in one day using readily available materials and student labor." "Yeah, but that's just how we approach engineering problems," Jake replied as if creating superior technology was a normal human activity. "We build things that work better than they need to because we never know what challenges we might encounter." Dr. Zextala realized that she had witnessed something far more significant than a cultural demonstration of human construction methods. Jake's excessive response to her simple request had revealed fundamental differences between human and alien approaches to technological development that would require extensive analysis to fully understand. As they tied up at the dock, she looked back at the vessel that had transformed her academic research in ways she had not anticipated. Her assignment had asked for a basic floating device and received something that exceeded her homeworld's most sophisticated water transportation technology. Dr. Zextala spent the following weeks analyzing the data from her cultural exchange assignment and found herself reaching conclusions that challenged everything her academic training had taught her about efficient problem-solving approaches. Her research notes filled multiple digital files as she attempted to understand the implications of what she had witnessed during Jake's construction project. The floating device that Jake had named the Overachiever at her suggestion remained docked at the university's marine facility, where it quickly became a popular attraction for both students and faculty. Dr. Zextala observed that humans use the vessel for purposes far beyond her original transportation demonstration, including recreational sailing, educational tours, and even romantic excursions that seemed to serve no practical function. The human approach to engineering problems demonstrates what I can only describe as beneficial excessive solution architecture, she dictated while preparing her research report for submission to the Centauri Academic Exchange. When presented with basic requirements, humans consistently respond with implementations that exceed specifications by several orders of magnitude. Her formal research paper grew longer each day as she documented examples of human over-engineering that she had discovered throughout the university campus. The marine engineering building alone contained dozens of student projects that followed the same pattern Jake had demonstrated during her assignment. Simple problems received complex solutions that provided capabilities far beyond original requirements. Jake stopped by her temporary office regularly to discuss her findings and answer questions about human engineering philosophy. Dr. Zextala found these conversations increasingly valuable as she attempted to understand why humans approach problems so differently from her own people. "Dr. Zex, I've been thinking about what you said about efficiency," Jake mentioned during one of their discussions. "On Kepler 442b, you build exactly what you need because your environment is controlled and predictable. But Earth environments are unpredictable, so we build things that can handle situations we haven't thought of yet. This insight helped Dr. Zextala understand that human over-engineering represented adaptation to environmental uncertainty rather than simple inefficiency. Her people had achieved technological advancement by eliminating variables while humans had achieved advancement by creating solutions robust enough to handle unlimited variables. Your floating device demonstrates this principle perfectly, Dr. Zextala observed while reviewing performance data from the overachiever's various test runs. I requested basic transportation, but you created a vessel capable of handling weather conditions that do not exist on my homeworld. Exactly, Jake agreed enthusiastically. We never know when we might encounter rough water or need to travel longer distances than planned. Building extra capability into the design costs almost nothing but provides huge benefits when unexpected situations arise, Dr. Zextala realized. That human engineering philosophy assumed worst-case scenarios as normal operating conditions, while her people's approach assumed ideal conditions would continue indefinitely. This fundamental difference explained why human solutions appeared excessive to alien observers yet proved superior in practical applications. The time approached for Dr. Zextala to present her research findings to the university community before returning to Kepler 442b. She prepared a comprehensive presentation that would serve as both her final academic report and her farewell address to the humans who had made her research possible. The presentation took place in the university's largest auditorium with an audience that included students, faculty, and several other alien exchange participants who had been conducting their own cultural studies. Dr. Zextala stood at the podium feeling nervous about sharing conclusions that challenged established academic theories about engineering efficiency. I came to Pacific Maritime University to study human approaches to basic problem solving. She began while displaying images of the overachiever on the large screen behind her. I requested a simple floating device and received a sophisticated watercraft that exceeds the performance capabilities of my homeworld's most advanced transportation technology. The audience responded with laughter and applause as Jake stood up briefly to acknowledge his role in the demonstration. Dr. Zextala continued her presentation by explaining how human over-engineering represented adaptation to unpredictable environments rather than inefficient resource allocation. On Kepler 442b, we build exactly what we need because our controlled environment makes efficiency possible, she explained while showing images of her people's simple floating platforms. Humans build what they need plus improvements, plus additional features, plus capabilities that might prove useful in situations they have not yet encountered. Dr. Zextala presented data showing that human solutions consistently outperformed alien alternatives when tested under variable conditions, despite requiring more initial resources and construction time. The extra capabilities that appeared excessive under ideal conditions proved invaluable when circumstances became challenging. This is not inefficiency, she emphasized while displaying comparative performance charts. This is adaptation to reality. Humans engineer for the universe as it actually exists rather than as we wish it existed. The presentation concluded with Dr. Zextala announcing her intention to recommend that the Centauri Academic Exchange establish a permanent human engineering consultation program for projects requiring robust solutions to complex problems. When you need a simple solution, ask anyone, she told the audience during her closing remarks. When you need the best possible solution, ask a human. But be prepared to receive far more than you requested. Jake raised his hand during the question period that followed her formal presentation. Dr. Zex, what was your first thought when you saw the finished boat? Dr. Zextala paused to consider her response carefully before answering with complete honesty. I thought I asked for a raft, and these magnificent humans built me a boat that could probably cross an ocean. Then I realized this is exactly why humans will likely be the first species to achieve practical interstellar travel, while my people are still perfecting our simple floating platforms. The audience erupted in laughter and applause while Dr. Zextala realized she had successfully captured the essence of human engineering in a single observation. Given any problem, humans would solve it. so thoroughly that they would probably solve several additional problems they had not known existed. As the presentation ended and people began leaving the auditorium, Jake approached the podium where Dr. Zekstala was gathering her materials. So what do you think will happen when you present this research back on Kepler 442b? I believe it will generate considerable discussion about our own engineering approaches, Dr. Zekstala replied while packing her tablet. My people may discover that controlling variables is less effective than building solutions. Capable of handling variables, she looked toward the window where the overachiever was visible at its dock in the marine facility. Your floating device has taught me that sometimes the most efficient approach is to build something that exceeds requirements because reality has a tendency to exceed expectations. Jake smiled with the expression that had become familiar during their months of collaboration. Dr. Zex, that might be the best summary of human engineering philosophy I've ever heard. Dr. Zekstala realized that her simple cultural exchange assignment had evolved into something far more significant than either of them had anticipated when she first requested a basic floating device.